Hey everybody, Mr. Judson here. So today we need to talk about the quotient rule. And quotient rule, if you think about the word quotient, it means we're dividing numbers, the answer to a division problem. And so really what we're talking about is how do I take the derivative when I'm dividing something? And so we're talking specifically about something like this. The derivative of f of x divided by g of x. Okay, I've got two things that I'm dividing, and I can't really simplify it. How do I take the derivative? This rule's different. I'm not going to go through and do the proof for this. It's a little time consuming. I think I'm going to go straight to the rule. And the rule is this. You take what's in the denominator times the derivative of the numerator minus numerator times the derivative of the denominator all over the denominator squared. And it's kind of funny because when I first learned this, there was this little saying that some kid in class said. This was at PLU 35 years ago, and I've never forgotten it. And it helps you with the quotient rule. What he said was low d high less high d low over low squared will go. What? Let me write it down. Low d high less high d low over low squared will go. It's kind of like this, I don't know, like a little nursery rhyme type thing. So low means the low part. D high means the derivative of the high part. So low d high less high d low over low squared will go. And if you can get this saying in your head, you will never forget the quotient rule. You'll never forget it. I still say this every single time I do the quotient rule. 35 years later, I'm still saying it. All right? I think the only thing that's really important here is just to remember you start with low. You know, because like what if someone goes, oh, it's high d low less low d high. It sounds the same. You know, so we just got to get that part. All right, so the way I kept it straight was in my head I was always going low d high, low voice. And that's how I knew what to start with. That may sound stupid, but you know what? If it works, then it works. That's all we care about. So one of the things I showed you the other day is that in calculus we use the variables u and v quite a bit. So if I was writing this, the derivative of u divided by v, and this is what you would see in our formula page, it's in our book, it would be low d high, so the low part, derivative of the high, less high d low all over low squared will go. And that's kind of the quick shortcut version of this rule. Okay? Now, usually if you have to use the quotient rule, there is no, here's an easier way if you just FOIL it. Because we're dividing now, we're not multiplying. So really the quotient rule is the quotient rule. Okay? Let's do an example of this. Let's say I have f of x equals 2x plus 1 over x squared, and we want to find f prime of x. What is it? Well, let's step our way through this. Low d high, so f prime of x is going to equal x squared times the derivative of the high part, which is 2, less high d low, so 2x plus 1. Derivative of the low part is 2x. All over low squared will go. And then we just have to simplify it. So this will be 2x squared. I'm going to think of this as a negative 2x times both of these. So a negative 2x times 2x, that's a negative 4x squared. Negative 2x times 1, that'll be a negative 2x. All over x to the fourth. If I add my like terms here, I get a negative 2x squared minus 2x over x to the fourth. I could factor an x out of each of these and then cancel it with what's in the denominator. So x times a negative 2x minus 2 over x times x cubed. Those will cancel. And there's my final answer. Sometimes what our book will do is they'll move the negative sign out in front and write it this way. 2x plus 2 over x cubed. So that negative sign, you can distribute it into the numerator, and then we would have the same thing that we have up there. Or you just leave it that way. Okay, it would be fine. I'll take it either way. There it is. There's our derivative. And just so that we can check this and make sure that this rule that we have now does in fact work, let's take the derivative of this on the graphing calculator. So if I want to check this, I'm going to do the derivative of, I got to put the numerator in parentheses, so 2x plus 1, close parenthesis, and then divide by x squared. And I want that derivative with respect to x. And so I hit enter. And there it is. What they did is they factored out a negative 2. Right? So instead of just factoring out that negative sign, they brought the 2 out with it, wrote that in front of the parentheses there. If we distribute that back, we can see that we get a negative 2x minus 2, which is what we have right there. So yeah, there it is. That's our quotient rule. Let me get you guys one to try. All right, you guys see if you can find the derivative of this one. All right, so f prime of x, I've got low, d high, derivative that's 1, less high, d low, derivative of sine of x is a cosine of x, all over low squared will go. And so I suppose now the question is, how do we simplify this? What we said last year was we really want one trig function if possible, no fractions if possible, and one term if possible. I don't think all that's going to happen on this one. But I could try and simplify it a little bit. I could say I've got a sine of x over a sine of squared of x minus x cosine x sine squared of x. And I can cancel one sine here with one of these sines. So now it's 1 over sine of x. And really that's a cosecant of x. Now can I do anything with this? Maybe. I could think of that as a cosine of x over a sine of x times 1 over sine of x. That's a cotangent times a cosecant. So x cotangent of x, cosecant of x. And I suppose if somebody's like, you really need to factor that if you can. Okay, I don't care, but somebody might. You could factor a cosecant out of each of those. I think the only thing I did was get rid of the fractions. I still have two trig functions, I still have two terms, and so, yeah, I'm not going to get rid of everything. Let's see what our calculator would have for this one. So I've got the derivative of x divided by sine x with respect to x. Yeah, they had this. So they didn't do anything to it. But you never know. Our book might do something to it. If you're taking the AP test, they may have this answer instead of that one. We just have to be ready for whatever comes at us. Am I okay if you stop right here? Yeah, I'm okay with that. It doesn't matter to me. If I really want, if I'm doing a derivative, what I really want to know is what's the slope of the tangent line? So if you think about it, which one would I rather plug numbers into? This one or this one? We don't have cosecants and cotangents on the unit circle. We have sines and cosines. So I'd probably want to stick with this, and so it makes sense to me to not simplify, but I can't promise you that on the AP test they wouldn't do that. Okay? It's multiple choice questions, you got to be ready for whatever they have. All right, so either one would be a good answer. All right, you guys go ahead and try this one. All right, so the derivative equals low d high. So the derivative of this would be 1. Derivative of a cosine of x is a negative sine of x. So the negative of a negative sine of x would be plus sine of x. Less high d low. So x minus cosine x d low all over x squared. So let's see, if I distribute this, I get x plus x sine of x. Negative 1 times both of these, that'll be a negative x. And then positive cosine of x all over x squared. And these two add up to 0. So now what I get is x sine of x plus a cosine of x over x squared. And I know that when people look at this, it's really tempting. Can I cancel this x with one of these? The answer is no, you can't. Not as long as you're adding or subtracting this or part of this to something else. All right? If it was just x sine of x over x squared, and this wasn't here, well then yeah, we could cancel those. But because we're adding or subtracting to something else, you can't do that. We talked a lot about that last year in pre-calc. So I would just stop right here. That's my answer. If I need to figure out the slope of the tangent line, this is probably going to be the easiest one to plug into. All right, let's do one last problem. All right, let's see if we can find the derivative of this one. All right, so f prime of x equals low d high, so I've got x plus 2. Derivative of the high part will be 2x minus 3. Less high d low, x squared minus 3x minus 10, and the derivative of the low part is just 1. All over low squared will go. Alright, so I'm going to go ahead and FOIL this. So I get 2x squared minus 3x plus 4x. So those will add up to just plus x. And then minus 6. Here I've got minus x squared plus 3x plus 10. And I still have, I'm not going to multiply this out just yet. As a matter of fact, when you're doing the quotient rule, usually people don't multiply this. And the reason is maybe something will cancel. If I multiply it out, I'm just going to have to turn right around and factor it again. So I'm going to leave it like that. And let's see what happens here. Let's see, 2x squared minus x squared, that would be just x squared, plus 4x, and 10 minus 6, that would be 4. And so I get x plus 2 squared right here. So now I'm going to factor this. Whoa, how'd that happen? If I factor that numerator, let's see, x times x, 2 times 2, and if they're both positive, we'd get 4x in the middle and 4 right there. Look at that. That cancels with one of these, and that cancels with the other one. So our answer is, remember, when we cancel those, we're saying we've got the same thing top and bottom, and when you have a fraction, top and bottom are the same, that means you just get 1 for an answer. So I wonder if anybody did this slightly different. I don't know if anybody thought about this, but right at the beginning, had I factored this, I would have had x times x, two numbers you multiply to get 10 and subtract to get a negative 3. And then I got x plus 2 down here. Those cancel. And so really that expression is equal to x minus 5. And what's the derivative of that? 1. Yeah, we could have made this problem a little bit easier, right? Sometimes you see that, sometimes you don't. That happens. We go through all the work and we get something really simple. Usually that means I probably could have factored and canceled something in the beginning. So now here I could say f prime of x equals 1. And if you would have done it this way, I'd say, good job. You saw something that maybe the rest of us didn't see. All right, that's what we have for today. Let me get you guys a homework assignment. All right, so number 8, we're talking about Wednesday's portion here. Page 129, we're going to do 11 to 16, 19, 22, 33, 36, 43, and 49. All right, there it is. Let's see, Thursday we'll start talking about derivatives of tangents, cotangents, secants, cosecants. We'll try and get all of our trig functions in the mix. You can kind of see things are starting to come fast, and there's just a lot of different formulas we have to remember. All right, I'll see you guys Thursday. Stay safe.